Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In this problem, we have a capacitor with circular plates connected to a EMF source, and we have that the maximum value of the displacement current is 7.6 microamperes, and we neglect the fringing of the electric field at the edge of the plates. We want to know what is the maximum value of the current in the circuit. So at any instant, the displacement current ID in the gap between the plates is equal to the conduction current I in the wires. So we have ID equals I. So we have that the maximum value will be the maximum value of the current I max, and this is 7.6 microamperes. For part B, we want to know what is the maximum value of the variation of the electric flux. We can write the variation of the electric flux in terms of the induced current, displacement current. So we have d phi dt max is equal to I max divided by epsilon 0, and we have the value here. So this is 7.6 times 10 to the minus 6, and the epsilon is 8.85 times 10 to the minus 12, and this gives us 8.59 times 10 to the 5 volts meters divided by seconds. Now for part C, we want to know what is the separation between the plates. So we can find the separation between the plates because we know the variation of the potential. So we have that ID epsilon 0 d phi e dt, but you can write this also as epsilon 0 a divided by d dv dt. And we have the V for the EMF generator. So we have that this is equal to epsilon 0 A divided by D omega cosine of omega t times the EMF value, so epsilon m. And we want to know what is the distance, so we can pick any instant of time. We can pick the instant of 0, so we have the maximum value. So we have here that, let me write this, see, we have B is equal to epsilon 0 A omega epsilon m divided by ID max, and plug in the values that we got. We have this as 3.39 times 10 to the minus 3 meters, where we use the cross-sectional area as the cross-sectional area of a plate, pi r squared. Now for the last part, we want to know the maximum value of the magnitude of the magnetic field between the plates at a distance of 11 centimeters from the center. So we can use the Ampere-Maxwell law and find that 2 pi rb is equal to mu 0 r squared divided by r squared id. So we got that the b is mu 0 I r divided by 2 pi r squared, and the maximum value then is just b max is mu 0 id max id and times r divided by 2 pi r squared, and we can plug values. This is 4 pi times 10 to the minus 7 I is 7.6 times 10 to the minus 6. R is 0.110 divided by 2 pi times 0.180 square. And this gives us a maximum magnetic field of 5.16 times 10 to the minus 12 Tesla.